What's up, guys? Welcome back to another NeetCode slash LeetCode grind video. I'm sorry, yesterday I was not able to upload as usual. And frankly speaking, the reason was because I had section selection today for my college, and that is kind of nerve-wracking in sense that you have to do. It's like a quick time event if you're familiar with that in like games like Call of Duty. So yeah, I was a little bit worried about it, and that's why I was just not able to do anything productive yesterday. But now that is over, and we have around, I guess, 2 weeks before I leave for my college. So I think we can give a good stream of content. Yeah, so I guess we'll just get another lead code grind. I think we did one linked list question, which was reversed linked list, right? And before I think we have to revise doing this 2 pointer approach, valid palindrome, threesome. हम लोग किए है. Container with most water we have done. I can still recall. Product of array except itself makes sense. Longest consecutive sequence. Hmm. Code decode strings. Then we have container with most water. Threesome also makes sense. Threesome कुछ part नहीं समझ में आ रहा, but any how do we do reverse, right? Reverse, no, not reverse linked list. Linked list cycle detection. So the one approach that we know is O of n space complexity, where we consist of an array that pretty much consists of all the visited nodes, and we check if any of the nodes has been visited before. If it is, that means that there's a cycle in the linked list. And then we learn about the two-pointer approach in order to find the cycle, which will give us the cycle detection O of n time while consuming effectively O of 1 space complexity. And the way we do it is, let's assume we have a linked list, right? Now let's say we have a slow pointer and we have a fast pointer, and they are pointing to the head. After some time, after this, the slow pointer will move by one node, and the fast pointer will move by first f node. Now, after this initial condition is set, so to speak, if there's a cycle in the list, the f and s will meet at some point, and this is guaranteed to happen in O of n time complexity. How? So if I imagine this is s over here and this is f, and the list, so what is the length away? This is 1 unit, and we have one, two, three. So f needs to travel 3 times in order to reach s. But every time s, so it needs to, so this is what, this the entire thing is the length of the array, right? Length of the list, which is O of n, which is n essentially. And it needs to pretty much do n minus 1, right? Because we set off the difference will be 1 initially after we set them off. At each increment, s will move by 1, which means it adds to the distance, while fast moves by 2. This because it's closing the distance. This is going ahead, right? So this increases distance, but fast then decrements. This effectively leads to minus 1. That means that each increment, the distance that f has to close to s slowly decreases, and it decreases by O of n minus 1 is the initial distance that it has to be set off, and this slowly decrements. That happens at O of n time complexity. So if we were to detect the cycle, we could just let them go and just see how it works. The way we do this is we will have a slow pointer and we'll have a fast pointer. They'll both point at head. Now, before we even start doing this, we need to check key our head. So while fast and fast.next is not null, what that will say initially is this means that our fast is not null. That means head is not null. If head is null, what this trying to say is head not null and head dot next not null, right? And the negation of this would effectively mean key head is null or head dot next is null. In both cases, the list does not contain does not contain a cycle. So that is just for that, and we will initially set them off as slow will essentially be head dot next, right? And fast will be head dot next connect, and we'll say if slow is equal to fast, then we'll return. Hmm. Oh, my bad, that's tough. Initially we're pointing at head, right, as we say, And hmm, seems like I have some things that are wrong in this. So initially they are both pointing at head. You know what? Let's do something like this. Slow is equal to head, fast is equal to head. Now while fast and fast dot next, we do slow is equal to head dot next, and fast is equal to head ka next year. Head ka next year. Um, right. So slow is equal to slow dot next, while fast is equal to fast dot next dot next. That makes sense. Yeah, and that seems to be pass, which is great. I was doing this in linked list. I was doing this in okay, interesting. Yeah, but if you see that's oh wow. You can see because we are fixing it to that. That's the mistake, right? So we'll just do slow dot next because it has to be variable, and fast will be fast dot next, and this will work obviously, right? So yeah, that is essentially how we detect. Okay, what was this? Okay, that is essentially how we detect a cycle in the linked list without using space. And yeah, that works. The initial condition, the only confusing part for me was this part, but this part ensures कि, even after we move over here, that obviously we have to move two steps, so one two, so this has to be not null, plus जहाँ पे हम लोग है वो भी null नहीं होना चाहिए, but that initial check is important, that this initial check will always pass after that point, right? Because again, unless this is null itself, right? So yeah, that understood. Great. I think I wanted to do a binary search question, so to speak. A normal binary search question. Just do binary search. Yeah, so we have binary search, which is again a simple question. Yeah, so the question is, given an array of integers nums which are sorted in ascending order and an integer target, write a function to search target in nums. So target exists, returns. Yeah, so this is pretty much very simple. Again, this is again a two pointer thing that we do. We say a left pointer is essentially 0. A right pointer is length of nums minus 1. And then while L is less than or equal to in this case, and I'll tell you why that is the case. We'll say middle is equal to L plus R y by 2, right? Or is this all shift F? If we do that, right? And if nums middle is equal to the target, it will essentially just return middle. L if nums middle is greater than the target, right? If it's for some reason the num value is greater than the target, then we will do r is equal to middle minus 1. Else this means the only way this is possible is if nums nums middle is less than the target, right? In that case what we would do is we'll do L is equal to middle plus 1, right? And if there's nothing of this sort happen, we'll just return minus 1, right? Yeah, that's pretty simple, and this is in running. So how does this work? Let's try to explain this. The way this works, let's assume we have 1, 2, 3, 4, and 5. And okay, I have this array and I know it's sorted. If someone tells me to find, let's say, the existence of, let's say, 5 in this, what I'll do is I'll just, so this is like 0, 1, 2, 3, 4, 5, right? I will come to the middlemost element, right? So we'll have 5 plus 0, which is 5. 5 by 2 is 2. So we'll come to the middlemost element, which turns out to be 3. Roughly middlemost. And I see, okay, is 5 less than 3 or is 5 greater than 3? Is If 5 is greater than 3, then I know that every number including 3 and before it will not have 5 by the very fact that the array is sorted. And I know that the 5 will be included on all the sides over here. That means I can change my pointer to this to be the left and this to be the right, and then I do the middle search again, and this time I get this is the middle, and that is voila, that is 5. That's why we have this clause over here. Now let's say I want to find 6. Now the same thing. Now 5 plus 3 is 8. 8 by 2 is 4. So 4 is not. Now is 5 less than 6? Yes, it is. That means everything including 4 and 5 are not gonna have 6, right? It will be over here. So then we change our left to point over here, and left and r point at the same thing. Now this is not a bad thing because this is valid, right? We haven't checked what is n at lr. That's why the intuition is that we let this happen, right? We let that happen. Then we do 5 plus 5, which is 10, pi to 5, and we check it. And let's say if this is not 6, let's say this was 7. We'd say, okay, well, is 6 less than 7? 6 is less than 7. That means it will be somewhere over here, but we know if we already have checked it. So we know what will happen is, um, because it's if it's less than that, right? Our L, so is 6 ज़्यादातर है, तो R will come over here, and this will very well just remove the while loop condition. That's why that L is equal to greater than equal to, that is valid, right? That makes sense. And I want to watch, this is weird, what is that about? YouTube.com, LeetCode. Right. I want to just watch through this video to understand.
Hey everyone, welcome back, and let's
And I think you guys can hear it just a bit. Let me try it.
write some more
Yeah,
NeetCode
yes.
today. So today let's solve the problem binary search. We're given an array of integers nums, which are going to be sorted in ascending order, and we're also given a target integer that we're going to look for. If the target exists in the array, then we can sorted. The target value could exist anywhere in this array, or it might not exist at all. When we start, we are considering the entire input array. How are we going to do that? Well, we're going to have 2 pointers. One pointer is going to be at the leftmost index, which is initially index 0. Another pointer is going to be at the rightmost index. These pointers,
One of the confusions I had while solving this, and that does sound dumb in retrospect, was it was pretty much like this is the formula used to do the middle value, to find the middle value. Like this is the formula, and it was like, how does that work? Because you're pretty much adding this point to this point, but then I realized, well, I guess that's how it works.
mean that we are considering the entire range. Now, if we could only look at one of these values, which one should we look at? Should we look at the leftmost? If we do that and we see that it's not equal to the target, then we've only eliminated one possibility and we still have to search all of these. If we look at the rightmost, similarly, it's not the target, so we've only eliminated one possibility. We still have to look at the rest of them. But if we look at the midway point, and technically either of these could be the midway point, the way we calculate it though is going to be literally taking the left and right indexes and dividing them by 2, which I think will lead us to this position. But approximately the halfway point. Why should we look here? Well, we can compare it to the target. It's not equal to the target. So what does that tell us? Have we only eliminated one possibility? No, because remember, the input array is sorted. So if this is not equal to the target, we should also ask, is it smaller than the target or is it larger than the target? In this case, it's smaller than the target. So if this is smaller than the target, then everything to the left of it is also going to be smaller than the target. So this was our midway point, we'll call it M, and we found that it's smaller than the target, so we can eliminate these 3 values from consideration, everything over here. How are we going to, represent that in code? Well, we're going to take this left pointer and then shift, these 2 points. It's going to be over, yes it is. So now we happen to be, I think it's 4 in this. The time, what we were trying to do, we the idea of binary search. Okay, so now the time complexity. If you know binary search, you already know that it runs in log n time, but let's quickly understand why. So we're not considering this example anymore, but suppose we had 16 values in the input array. Every time we go to the midway point, we either find the target, but if we don't find the target, we know we're at least going to eliminate half of the possibilities. So we would eliminate this down to 8. Now we're only looking at 8 values. We still don't find.
What the idea is key, at every point you either find the target or not. But if you find it, that's great. But if you don't find it, that means if you have 16, now you have only 8 targets to find from. Now if you don't find 8, then you have only 4 to search from. If you don't have 4, you search only from 2, and then 2, that means key exists or not. This will tell us. At worst, you're doing only these many times you're checking. This first time, second time, third time, fourth time, and fifth time. What do you mean by fifth time? That means, what does log 2 base n represents, speak wise? It represents how many times can you divide this n number by 2. Like, how many times can you divide this? Well, I can divide 16 by one time, I can divide it second time, divide it third time, I can divide it fourth time. I can start dividing it. If I see log base 2 of 16, it's equal to 4. That means you can divide 16 by 2 up to 4 times before you reach 1. Let's say log base of 20, 4 point this. That means you can keep dividing this until you reach the one element, right? And that means that the one element either it exists or not. So the worst case scenario for binary search is login. And it turns out login is super, super fast, because if let's say you have a billion entries, well, login is not that huge, right? It's just cutting the problem in half, in half, in half, in half, and then just it's a bit.
So So the question is, if we have a while loop, the while loop is going to run as many times as we can divide the length of the input array by 2. How many times can we divide it by 2? Well, if you remember from your math class, that is a math equation called log base 2 of n. This evaluates to how many times can we divide n by 2. And suppose it evaluates to be x. That's equivalent to saying that 2 to the power of x is going to be equal to n. Okay, but this is too much math. Maybe you don't even care, but that's
Oh man, come on, come on.
pretty much the idea. That's why our loop is going to run x times, which is going to be equal to log n. So it's not a big O of n algorithm, it's a log based function. Okay, so now
I mean, the simplest is pos is equal to 0 and neg is equal to 0. For num, this is the simplest answer as of now, right? Simplest answer as of now in nums. If num is greater than 0, pos plus 1, elif num is less than 0, uh, neg plus 1, else we just don't do anything, right? Then we just return max of pos and neg, right? That's like the simplest solution, right? This is like O of n solution, which I'm cheating a bit. Now the question is, can I solve this in binary search time? And I think I know how to do. Let's just take this for example, like let's just take this as an example. Let me paste this. Now let's say, okay, I have a left pointer and I have a right pointer. I calculate the middle to be this. Okay, this is the middle. Now if I know that the middle value is less than 0, then by the very definition of that, I know that every value that it has before it is also going to be less than 0, right? Because minus 1 ke baad, minus 1 should, if you have a number line and you see minus 1, you know iske baad wala sab minus 1 se kam hi hoga, right? That means everything from here, well, that turns out to be, I think I'll use these values and calculate the number and just add them up. Now the question is, now where do I do the binary search? Because now I have calculated this one to this one, right? Till the L of L, so to speak. Now where do I move my left pointer? Yeah, so let's say I move my, let's say, left pointer over here, and now the middle is this. Now if my middle is greater than 0, then I know that this element and the element that comes after this will also be greater than 0, so I can add them up. But the thing is, any element before it, I can't be sure, right? It could be 0. It could be it could be -1. This could very well be -1 over here, and this will still satisfy. So how do I find this out, right? Right? How do I find that out? And can you solve this in overflow? So that's the real question. Like how can I do that? Right, like because it's sorted, that means there's some virtue, right? If it's like, okay, let's just assume this, if I start from left, right, and over here this is my middlemost value, so I have covered almost this territory. Now if I search the next element, right, if I check the next element and I see the next element, let's see that, okay, um that wouldn't technically be login. Because we're like, okay, if it's 0, then just move ahead. We don't really care. We come to this element, and then we just say, okay, well, everything after this is just gonna be pretty much be like positive. So let's say we come over here. Um, 1, 2, 3, 4. Right, that will be there. And we put our left. This is done, and we come put our left over here and put our right over here. That's the thing, right? How do we now? Okay, if I put my left over here, put my right over here, I calculate the middle. I'm like, wow, this is positive, crazy. This means this is positive. I need to store this somewhere so this doesn't get confused for it. Also, I could realistically just keep this because technically speaking, ये zero हो सकता है यहाँ पे. You can think about it. That could still very well be 0. Think of lower and upper bound. You're gonna get. What does this deal mean? Wow, crazy. So binary search is just tougher on this, right? Um, okay, this stopped crazy. How do I do this? How do I do this? Think of lower and upper bounds. I okay, we'll come to this. Oh man, I give up easily, right? This question now it's saying, can you use it in log n time? Can there be duplicates? There can be duplicates. Hmm. This makes sense. Another question is like, okay, um, also there could be thinking -1 यहाँ भी आ जाए, to be honest. So what do we do? I guess this is done. So my logical sense would be कि after this we say L is equal to middle plus 1. Right? अगर greater than 0 है, right? For example, greater than 0 चल रहा है, मतलब 2 -1 -1 1, मतलब यहाँ पे आ गए हम लोग. ठीक है, अगर मतलब वो 0 से ग्रेटर है, मतलब अगर ये हम लोग का मिडल है, ये हम लोग का आर है, सो 0 1 2 3 4 5, मतलब इसको और इसके बाद वाला सब 0 से बड़ा होगा ही होगा, एंड पॉजिटिव होगा, क्योंकि अगर ये 0 से बड़ा मतलब इसके बाद वाला ही 0 से बड़ा होगा. मतलब what I could do is I could say 5 minus 2 is equal to 3, plus 1 which is equal to 4, including this one too. So I could say something like pos is equal uh, r minus middle plus 1. And what I can do is I could pretty much now put r over here, so I can say r is equal to middle minus 1. I can put r over here and L over here again. L तो इधर ही रहेगा. एंड क्योंकि मैंने यहाँ तक कैलकुलेट कर दिया तो 5 minus 2 3 हो गया, 5 minus 2 plus 1 हो गया, एंड r को मैंने मिडिल minus 1 कर दिया. ठीक है, अब ये यहाँ पे हो गया. अब इसने फिर से कैलकुलेट किया, 0 आ गया, राइट? 0 आ गया, तो अब 0 पे चेक किया इसने, तो ये आया कम. सो मिडल माइनस एल प्लस 1 1 इंक्लूड किया, एंड इसने एल को प्लस कर दिया यहाँ पे. I think I may have gotten this. We have to do this same. L and R अब दोनों सेम आ गए. ठीक है, अब वो भी कम हो गया, तो कजू सेम पे है तो माइनस प्लस 1, एंड वो ओ वाओ, चैट दिस माइट वर्क ना. बट प्रॉब्लम ये है चैट, प्रॉब्लम अब ये आ रहा है कि फॉर एग्जांपल अगर ये ऐसा आ गया, राइट? अगर ये लिस्ट आ गया तो 0 1 2 3 4 5 6, सो 6/2 3 हो गया, तो यहाँ पे हम लोग आ गए, हम लोग यहाँ पे आ गए. दिस इज द प्रॉब्लम. हम लोग यहाँ, and one thing I'll just say is return max of neg and cos, right? All shift F. मैंने all shift F किया भाई, नहीं हो रहा है. craze. Anyhow, this logic seems to work. ठीक है, but the moment 0 आ जाता है, and also one more thing, this will be infinite loop. अगर इधर कुछ किया नहीं ना हम लोगों ने, तो ये infinite loop हो जाएगा कुछ कुछ टेस्ट केसेस में. आई डोंट थिंक ये टेस्ट केस पास भी करेगा, बट आई हैव डन अ ड्राई रन, एंड ड्राई रन में तो भाई हो रहा है, राइट? अगेन हाँ हाँ, यहाँ 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 पे ही हम लोग की बस रुक रही है. सो क्या है ना, यहाँ पे 3 पे आ गया. नाउ व्हाई आर देयर डुप्लीकेट zeros भाई? व्हाई आर यू मेकिंग माई लाइफ इवन टफर? लाइक इसके बाद भी 0 आ सकते हैं. एक काम करते, डिवाइड एंड कॉन्कर करते हैं. ओके, मतलब हमें ये वाला साइड देखना है, एंड यहाँ पे L है, यहाँ पे R है, एंड ये हम लोग का मिडल है. देखो भाई, यहाँ पे क्या है ना, यहाँ पे we can go either ways. We can put R over here and we can then calculate क्या हो रहा है. यहाँ पे ये है, ओह वाह ये कम आ रहा है, क्रेजी है. अब यहाँ पे L and R है, राइट? यहाँ पे आ गए, यहाँ पे कैलकुलेट किया, एंड देन LRR, कोई तो कुछ होगा, प्रॉब्लम ही नहीं हो जाएगा, राइट? मतलब ये कट हो जाएगा. हाँ, Let's assume simple case, I guess. 0, 1, 2, 4, 5, 6. I mean, अगर कोई डुप्लीकेट्स नहीं होता ना, तो पता है मैं क्या बोलता यहाँ पे, बिकॉज यहाँ पे डुप्लीकेट्स है। यहाँ पे डुप्लीकेट्स नहीं होता, पता है मैं क्या बोलता। ठीक है भाई, यहाँ पे ये है, यहाँ पे लेफ्ट है, यहाँ पे राइट है, और ये हम लोग का मिडल है। काम करो, 3 - 0 क्या आया, 3 आया, 1 2 3 बराबर। तो नाउ दिस विल नॉट वर्क बाय एनी हाउ, बट मैं करता नेग इज इक्वल टू मिडल माइनस एल, एंड मैं करता पॉज इज इक्वल टू आर माइनस मिडल एंड ब्रेक द रूल। This is not gonna work. 6 minus 3 3. This is not gonna work. The only reason why I'm doing this is because I want to somehow pass a test case. There's no way this is working. There is no way this is working. एक टेस्ट केस में फेल होऊंगा। these लीड कोड वाले लोग, पता था, मुझे पता था यार, ये लोग बहुत तेज है, इन लोग कुछ ना कुछ झाल मूरी डालेंगे हम लोगों को फेल करवाने के लिए। देखो गाइस, आई नो कि दिस पार्ट ऑफ माय एल्गोरिथम वर्क्स रियली वेल। This part of my algorithm is working well. I just don't know what to do with this, essentially this part of the algorithm, to be very much honest. Like, क्योंकि अगर जीरो आ गया ना भाई, तो प्रॉब्लम हो जाएगा हम लोगों को। लेट्स एक टेस्ट केस देख लेते हैं। यू सी द टेस्ट केस में भागेगा भाई, टू बी ऑनेस्ट। लाइक, ये टेस्ट केस में there will be no problem. Why wouldn't there be a problem? I'll show you what the actual algorithm is, so to speak. यहाँ पे मिडिल क्या है, 0 1 2 3, तो 3/2 1, मतलब ये हम लोग का मिडिल है। नाउ मुझे पता है यहाँ से यहाँ, तो हम लोग पॉज में 2 डाल दिया। नाउ अब क्या होगा ना, एल यहाँ आएगा, आर यहाँ पे आएगा, 3 + 2 5 होगा, 5/2 हमारा 2.5, मतलब 2, ये हमारा मिडिल आ गया। ये चेक किया जाएगा क्या ये है, और इसके क्योंकि ये मिडिल है और एल एल भी यहाँ पे ही है, ये खाली 1 ऐड होगा, देन ये यहाँ पे आएगा, ये चेक किया जाएगा, एन एक और 1। दिस वर्क्स फ्लॉलेसली फॉर दोज केसेस एज वेल, but the issue is the moment zero is involved, bhai sahab. um what can I think about this, what can we do in this case, right? अगर zero पे आ भी गए आप लोग, we want to ignore zero, right? Because zero neither positive है nor negative है। one thing we can do is, जहाँ पे जीरो उसके आगलू बगलू है, वहां पे हम लोग देंगे ही नहीं। ah It's like I almost have the question under my grips, but मुझे जीरो वाला सिचुएशन का पता ही नहीं है क्या करना है यार, टू बी वेरी ऑनेस्ट। लाइक, क्या जीरो में क्या कर सकते हैं, अगर ये लेफ्ट पॉइंटर है एंड ये राइट पॉइंटर है। नाउ अगर लेफ्ट पॉइंटर एंड मिडिल वैल्यू सेम नहीं, um, one thing I can do is I can keep pushing this back, right? तब तक बैक, तब तक जीरो ना आ जाए, and it stays greater than equal to r, right? One thing I can do now, I don't know whether this will work or not, but one thing we can do is, while nums dot middle is not equal to, is equal to 0, and middle value is greater than equal to l, we'll do middle is equal to 1। तो इससे पीछे जाएगा, क्या मिडल इक्वल टू 0 है एंड क्या ये बड़ा है, हाँ बड़ा है, यहाँ तक आ जाओ, यहाँ तक रुक गया, मतलब आपका नेग क्या होगा, नेग अब हम लोग का यहाँ पे मिडल है, राइट? दिस इज आवर मिडल वैल्यू। एंड यहाँ पे L है, तो 0 1 2, सो 2 माइनस 0 2 आएगा, राइट। फिर से यहाँ पे हम लोग क्या करेंगे, राइट, यहाँ पे हम लोग क्या करेंगे, we'll do middle minus L plus 1, right. Actually, to be honest, that's not how I want to. Current will go middle, and I will say current. I think I know what I'm doing. I want to save that value, right, and then I'll change middle. So okay, now का while nums का middle is equal to 0 and middle is less than or equal to r, we will do middle plus equal 1, and we will do pause is plus equal r minus middle plus 1, and we will do break. This could either be the biggest mistake. Okay, middle, I didn't save that. List index out of range. कैसे out of range होगा? Hmm. That wouldn't still matter. Yeah, that wouldn't really care matter, to be honest. Like, because this is okay. I know this is how middle is calculated, and current takes middle ka value, and then it works with that, and then we put that back in, right? And again, that will be issue. I'm just trying to figure out what am I doing wrong over here, right? So okay, so, okay. Um, hmm. Okay, let's not worry about this. So all the nums left of 0. Um, yeah. So does it pass the test cases though? Okay. Uh, this is all the nums. So all the nums to the all the nums right of 0. So I guess I will do. Okay, let's not change that. Right. Let's do something like pause is. I mean, C pause is equal to middle. We make another one middle, and we'll say while nums C pause is equal to 0 and C pause is less than or equal to R. We will do C pause is plus equal 1, and essentially we'll just do pause plus equal. We will do R minus C pause plus 1. Does this work? The same issue. Um, hmm. Let's figure out why. Let's debug this. Also, weirdly, it's running on. Is this running on the test case? Okay. Interestingly, it passes the test case, but it fails on this. Uh, it fails on this actually 0 0. Why does it fail on 0 0? All the nums left of 0. So while uh, which one does it say? This one, right? इसमें बोलता ना प्रॉब्लम है बाहर. Okay, ठीक है. Um, so 1 by 2 is essentially 0, so 0, right? So while c pos is equal to 0 and c pos is less than r, so इसमें ये l है and ये r है and basically middle अभी है and it's saying while this is and c pos is less than equal to c plus 1, so ये यहाँ से यहाँ आया. ठीक है. Okay, I think I understood what's wrong. um the issue is कि क्योंकि ये अभी तक है तो ये यहाँ पे आया, यहाँ पे भी इक्वल टू है, राइट सब है, तो सी प्लस वन. नाउ अब ये एक्चुअली एग्जिस्ट नहीं करता, राइट? दैट इज द इशू. ये एक्चुअली में डज नॉट एग्जिस्ट. सो हाउ डू वी डू दैट? इफ आई डू दिस एज दिस, then okay, um actually um what I want to check is this, right? C plus 1 should be less than that. Okay, again c plus is over here, c plus 1 is this, right? Is this less than equal to r? Yes it is, so then we do c plus 1 over here. Now क्या c plus 1 less than r है? नहीं है. Okay, I don't know what chat, I don't know if I'm able to get this. I think I'm very close on understanding this question, but yeah, I'm not going to spend way too long because we have other questions to do. But yeah, this is one of my questions that I will try to figure out later, which is interesting. So yeah, just give me a few minutes. Let me just go get a washroom break real quick. We're back. Yeah, so like a pussy, I'm gonna leave that question and try to do the other questions of binary search and stuff. Merge to sort. I actually tried doing this. I gave up. Reorder list, gave up. Binary search. क्या है? What? Search array? What do you mean by that? Um, then we have find minimum. Find minimum in rotate. I tried solving this. I think the better solution search in rotated sorted array. So this one is like try to find out. The idea is quite simple. The thing is you are given a rotated search array and you have to find out certain things. So the question is you need to find out you need to essentially find out the starting point and the end point and then figure out there. For example, over here, if you have this array, right? If so, this is like first of all rotated as hell. If I can find out that this is my L and that this is my R, I can actually perform over here binary search using modulus. So our first step would be to find L and R. And so how do we do this in this case? I mean, we could do some sort of like O of n search for the maximum element, O of n search for maximum element, and then log n. But this, this would be an O of n thing, and that very well we could just search this. Log n plus log n will still be log n, even though there's a 2 over here, which you can do something like log n square, but that doesn't really matter. Um, if I do left over here, right over here, and if my left element is bigger than my right element, so to speak, because 3 is greater than 2, that means I know it's rotated, right? Um, and then I know key, because that means all the greater elements are towards this side, and to the AC side, all the greater elements are towards this side. Even if we had 2 and 3 over here, I would still say the greater elements are that side. Let's search it up, chat. Let's search it up. Is this, what is this? What are the discussion tabs on this? No brain solution. What? Uh, uh, Linked list. Meh. Always look at the discussion page, to be honest. Ah, two-step verification, my ass. Oh my god, chat. We haven't solved a new question today. I solved this question by myself, which I'm very happy about. Two pointers is great, but we have to go into this sliding window. This is. I could do these three. I'm not doing this. This problem was just shitty. Let's see. It's sliding window. Okay. What do you mean by sliding window in the context of DSA? What do you mean by sliding window? Used to process contiguous. Ah man, it's like I think I can solve this. I think the logic for this would be कि we just I think what much better way of doing this would be something like for I actually what better way would be I is equal to 0 while I is less than this, right? And yeah, so um, okay. So we come at A, right? So we come at A, right? Um, right? And so okay, let's just try to in a sense make that work. Sorry, my bad. Right, so we first come at 0, 1, 2, 7. Okay. So substring is nothing, and we can go max length is equal to 0 and max length or the length of the substring that I made. Anyhow, so अब क्या होगा ना, substring जैसे ही आया हम लोग ने substring एक empty initiate किया and is repeated को हम लोग बोला false. Now क्या a substring में पहले से है? नहीं है, मतलब substring में अब a आ गया एंड i प्लस प्लस वन मतलब i अब यहाँ पे पॉइंट करेगा, राइट? नाउ क्या b है? नहीं, तो b आपका यहाँ आ गया एंड i आपका यहाँ पे पॉइंट करेगा. क्या c है? नहीं, करेक्ट, देन आपका i यहाँ पे पॉइंट करेगा. नाउ क्या 3 वाला है? यस है, मतलब हमारा सबस्ट्रिंग बना ये, राइट? हम लोग ब्रेकआउट हो जाएंगे लूप से एंड वी वांट आवर आई टू बी प्रीटी मच इक्वल टू ये जो लास्ट वैल्यू हम लोग जो छुए, जो यहाँ पे स्टोर होगा, right? That will be pretty much stored over here. So I think I can say something like j is equal to I, and over here I could say j and I think it's something like while j is less than the length of this, you can say break, um, and we can say this is equal to j. So अब यहाँ पे थोड़ा माइक्रो ऑप्टिमाइजेशन, मतलब माइक्रो तो ऑप्टिमाइजेशन नहीं है, मतलब ठीक ही है, right? So up, let's try to rewind this again. So now we are this is O of n, this is happening in O of n time. So right, so again while I is less than 0, 1, 2, 3, 4, 5, 6, 7, right? I 0 हुआ, j भी 0 होगा, तो j start हुआ 0 पे. now while j is less than s, j j, ठीक है. नाउ अभी सबस्ट्रिंग क्या है? सबस्ट्रिंग कुछ नहीं है, तो अभी हम लोग ए पे आ गया, ए सबस्ट्रिंग में है, नॉट इन ए, सो ए यहाँ पे आ गया एंड हमारा जे अब हो गया 1. अब हम लोग यहाँ पे आए, क्या ये है? नहीं, तो जे अब हो गया 2, राइट? सी, क्या सी है? नहीं। बी है? नहीं। तो अब हमारा यहाँ पे हो गया, क्या सी है? नहीं। क्या ए है? हाँ, ए है। तो मैक्स लेंथ क्या हो गया? मैक्स ऑफ मैक्स लेंथ ऑफ द सबस्ट्रिंग, राइट। अब मैंने ब्रेक कर दिया। जैसे ही मैंने ब्रेक किया, अब आई का वैल्यू 3 पे आ गया, राइट। नाउ दिस लूप रन्स एंड हम लोग, अब जे यहाँ पे आ गया एंड जे फिर इसको लेके चलेगा, सेम चीज़ करेगा जे यहाँ पे। जैसे अभी ये आएगा, राइट, तो जे चेक करेगा, ओ शिट आ गया, तो ब्रेक करेगा एंड फिर आई जे यहाँ पे आ जाएगा। देन अब जैसे ही जे यहाँ पे आया, जे जे आया यहाँ पे, फर्स्ट ऑफ ऑल तो एम्प्टी सबस्ट्रिंग है, तो पहला वाला तो मिस ही होगा। तो बी आया, फिर यहाँ पे हम लोग आए, फिर यहाँ पे वेल वो तो है सबस्ट्रिंग में, तो मैक्स लेन अपडेट किया, ब्रेक किया एंड यहाँ आई हमारा ये हो गया, राइट। नाउ हम लोग किया वाइल जे इज लेस देन लेंथ। आई थिंक दिस माइट वर्क, chat, this might work, chat. Longest substring का लेंथ 0 मान के चलते हैं अभी। लेट्स डू वन मोर थिंग एंड ऑल्सो एक और चीज़ 0 मान के चलेगी, आई इज इक्वल टू 0,0, right? Yeah, so now what I'm going to do is I'm going to do while I is length then s, right. I'm going to do substring is equal to this. I'm going to say I is equal to j. Now while j is less than length of s, right, and I'm going to say if j not in substring, नहीं है substring में, we'll do substring plus equal sj and we'll do j plus equal 1, else है मतलब we will say crazy. Why? Why is this the way it is? Longest substring is equal to max of longest substring and length of substring, and we'll just break out of this loop and we will set I, so I j by ये क्या कर रहा हूँ मैं, j is equal to I, right, and I is equal to j, and then I'll return longest substring. um okay. Why so, right? Let's just run the test case first of all. I want to run the test cases. Okay, now let's see why, what in what test case we failed. तो यहाँ पे empty है, then ठीक है। now क्या ये है? नहीं है। क्या ये है? ओके वेट पॉज, false. ओके, 1, ऐसा क्यों है? सो हम लोग यहाँ पे लेट्स से यहाँ पे एक एम्प्टी ब्रैकेट डाले, यहाँ पे जे आपका आया, सबस्ट्रिंग भी अभी कुछ नहीं है, खाली। तो अभी यहाँ पे ये आया, मतलब क्या ये अभी है सबस्ट्रिंग में? नहीं, नहीं है। तो हम लोग सबस्ट्रिंग में इसको ऐड किया तो कैसा लगेगा? सी दैट इसको हम लोग ने ऐड किया सबस्ट्रिंग में एंड जे जे प्लस 1 कर दिया। हाँ, मैं समझ गया गलती क्या है, क्योंकि जैसे ही जे प्लस किया, जे यहाँ पे आ गया एंड ये टेक्निकली ये फुलफिल नहीं हो पाया, तो क्या हुआ कि ये रन ही नहीं कर पाया यहाँ पे टेक्निकली. सो यू नो व्हाट वी विल डू इज बेटर ऑफ वी विल जस्ट कम आउट ऑफ दिस लूप. ये यहाँ पे हम लोग इसको सेट कर देंगे, इससे प्रॉब्लम सॉल्व हो जाएगी. इज इट रनिंग द टेस्ट केस? ओके, टेस्ट केस वर्क्स. यहाँ प्रॉब्लम क्या है? आउटपुट एक्सपेक्टेड. ओके, टी वी. क्या कॉपी नहीं कर सकता क्या? अच्छी बात है. Seems like what they're doing is BCA. BCA कैसे हो गया? आई ओके. उससे तो भाई तो I think the way they want it to be done is something like in order of this. Right? So ऐसी मच क्या आने वाला है यहाँ पे कि let's just say I is equal to 0, while I is less than right, substring कुछ लिए. मैं समझ गया ये लोग क्या चाहते हैं. सबस्ट्रिंग कुछ लिए, हम लोग इसको चुने. नाउ वाइल इसको हम लोग जे को मान के चले आई. ठीक है, जे को हम लोग ये आई ना, वाई जे इज लेस देन द लेंथ ऑफ एस. ठीक है, अब हम लोग क्या करेंगे इसमें, हम लोग देखिए कब तक ये जा सकता है, राइट, कब तक ये जा सकता है. सो वी विल एसेंशियली डू दिस if sj not in substring, we'll go, wow, that is great, we'll do substring plus equal sj, so we often square solution by the way, um, and we'll do, well, we'll just do j plus 1, and else हुआ भी तो हम लोग ब्रेक कर देंगे. एंड नाउ वी विल जस्ट से कि ठीक है, लॉन्गेस्ट या जो भी मतलब मैंने बकचोदी करने की कोशिश किया, लॉन्गेस्ट सब स्ट्रिंग इज इक्वल टू 0. यहाँ पे क्या करूँगा मैं, longest substring will be equal to longest substring equal length of substring. ठीक है, now that's it, that's how we will update it. And yeah, that's pretty much how we will do it. And यहाँ पे हम लोग बस कर देंगे, यहाँ पे हम लोग बस कर देंगे I plus equal 1, and we'll print longest substring 3. That's how they want this to be. They don't want this to be here. And if I run that, basically in this place they want I plus 1. This will be of O of n square, because this will be like, okay, ठीक है, ये नहीं है, यहाँ तक देखा कितना है, फिर यहाँ तक चेक करेगा, some sense like that. Okay, yeah, this is very slow, and I know what it does. It's basically बोला, okay, देखिए A B C A, okay, shit, okay, आ गया, okay, B C B B, shit, ये यहाँ तक ही आएगा, crazy, C A B C, shit, यहाँ तक ही आएगा, A B C B, great. So A B C B, oh, B आ गया, shit, यहाँ तक ही आएगा, B C B, हाँ, यहाँ तक आएगा, C B B, हाँ, यहाँ तक आएगा, P B B, यहाँ तक आएगा. So you could assume कि pretty much at every iteration, so we're going n iteration, for each of the single iteration, because for each of these iterations we are checking n minus 1. So uh, roughly we are doing pretty much n minus 1, n minus 2, it'll be O of n square. This is O of n square essentially, right? This is O of n square. And how do we do this in the sliding window? um, how do we do this in sliding window type, matlab, like what do we even mean by sliding window? Longest substring without repeating characters, longest, yeah, I did this chat, मैंने इसको solve कर दिया, and total time complexity, O of n तो नहीं है. What's the funny thing we can do is we can say ठीक है, A B A B C A रिपीट हुआ, यहाँ से हम लोग ने A को छोड़ दिया, A रिपीट हुआ मतलब, ये रिपीट हुआ मतलब इसका हम लोग ने स्नैपशॉट लिया है, हम लोग फिर यहाँ से स्टार्ट कर रहे हैं. हाँ, ऐसा हो सकता है ना, इफ आई कैन फिनिश दिस इन दैट अलॉटेड टाइम, बट द वे आई थिंक अबाउट दिस वेरी सिंपल. क्या कर सकते हैं हम लोग, A है, फिर we'll include B, so we'll do A है, B है, C है, and then we see, oh shit, A आ गया. हम लोग क्या करेंगे ना, हम लोग इस A को हटा देते हैं, so we only include, essentially we just making a window so to speak. ऐसे विंडो बन रहा है, बन रहा है, बन रहा है, बन रहा है, oh shit, ये A आ गया. हम लोग क्या किए, इसको हटाए पहले, फर्स्ट ऑफ ऑल इसका जो लेंथ है इसको हम लोग कहीं मैप में डाल दिए, इसको हम लोग हटाए, एंड फिर हम लोग यहाँ से स्टार्ट किए, ओ ओ ओ ये आ गया, तो फिर हम लोग इसको हटाए, फर्स्ट ऑफ ऑल इसका हम लोग ले लिए, फिर हम लोग चलाए इसको, ओ ये आ गया इसका मैप. Think that could be done. अब how will we implement this is a very good question. I like that question. It's one of my best questions. Let's see how we'll implement this. So मान के चलते कि हमारा I है. Again, I think same ही logic रहेगा यहाँ पे, ज़्यादा change नहीं है. So while कितना टाइम मेरे पास अभी बचा हुआ, 9 मिनट, 9 मिनट चलाओ. I is less than this, right? And हम लोग एक substring मार देंगे. यहाँ पे and longest substring. Now while will j is equal to I, while j is length, ठीक है, फिर हम लोग क्या करेंगे, if sj not in substring, we will say substring plus equal sj. इधर क्या किया था हमको, j+1 else break this. अब देखो क्या होने वाला है यहाँ पे क्या होगा ना, अब क्योंकि a b c यहाँ तक ठीक है, अब भाई साहब a आ गया, राइट, a आ गया, इसमें अब a आ गया, मतलब दिस ओवर हियर we got a. now instead of breaking the loop, what we can do is, क्योंकि हम लोग के पास a आ गया है, राइट, to be honest this could be anything, this could be b also. So remove from value in a string in Python. What I mean by that is, let's say this is ABC. If I do s dot replace, I think that is what we need to do. So essentially इसको अगर मैं हटा दूँ, so yeah, because हम लोग को a आ गया और we got some repeated value. Okay, so मैंने क्या बोला था, अगर ये आ गया तो we basically loop. First of all, we save this somewhere. So we say longest substring is equal to max of longest substring, length of this substring. Right, तो हम लोग इसको loop कर दिए. Now what we will do is we will do substring dot replace, and मुझे पता है कि ये replace होने वाला है, so I could say something like sj with nothing, right. तो इसको हम लोग हटा दिए, and now I can say substring plus equal sj. तो अब ये include हो गया हम लोग के, ठीक है, right, great. एंड इन दोनों के एंड में भी हम लोग को j प्लस इक्वल 1 करना है, हो गया ये इंक्लूड. अब हम लोग यहाँ पे आए तो अब b मतलब है इसमें, राइट, b इज ऑलरेडी इन द सबस्ट्रिंग. सो हम लोग इसका कैलकुलेट कर दिए कितना है सबस्ट्रिंग है इसका लेंथ, एंड बेसिकली रिप्लेस दैट, एंड हम लोग इसको ऐड कर दिए. तो अब ये यहाँ तक ऐड हो गया एंड j आगे बढ़ गया. चैट दिस माइट वर्क चैट. Also, why do we need a loop for this? Right, 7, crazy. Why so? Let's see क्या हो रहा है यहाँ पे. So we have, I think I might be able to, how much, 5 more minutes, 1 2 3 4 5 6 7, while less than 7 we'll have a substring on top over here. So अब क्या a है, नहीं, तो a ऐड कर दिया गया. क्या b है, नहीं, b को ऐड कर दिया. क्या c है, नहीं, c को ऐड कर दिया. क्या a है, हाँ a है, राइट. सो यहाँ तक आया. नाउ क्या a है, यस a है, राइट. इफ नॉट इन दिस ए है, तो लॉन्गेस्ट सबस्ट्रिंग, फर्स्ट ऑफ ऑल हमें इसका लेंथ जितना था हम लोग ने पहले एक वैल्यू में डाल दिया, राइट. तो इसका लेंथ क्या था, 3 था. सो वी डू मैक्स ऑफ लेंथ ऑफ सबस्ट्रिंग विच इज ए बी सी. देन वी विल डू ए रिप्लेस नथिंग, एंड देन वी विल ऐड दिस सबस्ट्रिंग इन दिस, राइट. एंड जे यहाँ पे था, इसलिए इतना सब हुआ. अब j+1 करेंगे. अब एसेंशली ये हमारा हो गया ना. फिर से सेम होगा, हम लोग इसका कैलकुलेट कर देंगे. अभी तक उसको हम लोग ने ऐड नहीं किया. पर ये 7 क्यों बोल रहा है? दैट इज़ अ गुड क्वेश्चन. इट्स अ गुड क्वेश्चन. 0. um, I know my solution is right though, because it does account for those things. So hmm, how do I make this work right? Okay, so this why is that not? I know what's happening. So a, okay, while j is less than length, j का 0 नहीं है, प्लस 1 नहीं है, 2 नहीं है, एंड जैसे ही उसने इंक्रीमेंट किया 3 में, बूम, ये कभी रन ही नहीं हुआ. इसका मतलब है कि we found one character repeating, right? We found one character that was repeating, hence we just lock that one in. जितना भी substring का है, essentially, you know what, much better is we do substring, I mean ठीक है, बात बराबर है. We solve that in, we replace it with nothing, so that वो exist नहीं करता, obviously that would ruin our metric, and then we just add that as we had, and we just go ahead. But cases like that उसमें ले रहा नहीं है. Again, why does it not take for this value? मुझे एक बार चीज़ समझना है, हो रहा क्या है यहाँ पे. यहाँ पे 7 आ रहा है. 7 क्यों आ रहा है? ए बी सी आ रहा है, एंड यहाँ पे ए बी सी ए आ रहा है, विच इज़ इंटरेस्टिंग. क्यों आ रहा है? ए बी सी, उसके बाद ए ऑफ कोर्स हुआ होगा कि ए है, राइट? बोला होगा कि ए है बिफोर रिपीट after repeat. Okay, I think I might figure out the mistake. ABC. ये क्या हो रहा है? इसमें प्रॉब्लम क्या है? ये तो एंड ऑफ द लिस्ट ही ऐड कर रहा है ना इसको. हाँ. um, uh, यहाँ पे हो रहा क्या है? बिफोर मतलब हम लोग बनाए, obviously we just append this. ये तो बकचोदी हो रहा है ना इधर. Element to replace SJ, ये भी सही आ रहा है. After repeat तो ये तो गलत ही है ना. From ABC, how to remove A in a string in Python. मतलब, is this some kind of joke? I know it, I know. ये क्या है? इसको करके भी क्या फायदा? एक ही फर्स्ट ओनली वन ईयर करेंस रहेगा ना. ये कैसे हो रहा है? Okay, I need to see my code. Before repeat ABC. After repeat कैसे हो रहा है यार? Yeah. This happens when you don't understand immutability, chat. This happens when you don't understand immutability. Anyhow, so pretty much this condenses to something like while I is less than length of s, we can have a substring as well. Substring. Now pretty much we just copy this. If s dot I in not in substring, um, something over here. Yeah, I think that's all right. Something like that. क्या कर रहा हूँ मैं? Substring plus equal. I'm so dumb. I'll never forget that now. Longest substring is equal to max of longest substring, length of substring. And now we'll say substring is equal to substring dot replace sj, and ठीक है. Let's try the test cases on this. Error, j is not defined. My bad. यहाँ पे भी issue आएगा. Muscle memory can't blame. Okay, wrong test case. क्या हुआ? Output 4, expected 3. क्यों आ रहा है? P W W. तो ये क्या हुआ होगा इधर कि W रिप्लेस, समझ गया मिस्टेक क्या है. W रिप्लेस हो गया, बट टेक्निकली ये नहीं हुआ ना. दैट्स द इशू. P W W. That makes sense because यहाँ पे इसीलिए बना पा रहा है. Right. Then only it could be. But then if it's the case that it's not equal to it, um, then I think it's, yeah, I think then it's better that what we do is if it's then we can do that. But if that's not the case, we can pretty much do something like substring plus I, pretty much. भाई क्यों नफरत हो गया है? Yes, if it's not equal to, then we just put that. Yeah. Hmm. Yeah, this works good enough because this changes the substring, because we say, okay, well, you know that, because in this case, right, PWWK, so we say, okay, fine, PWWK does not really matter that much. Right. So what we do is we say, okay, just start substring from W, and yeah, I say WK. Okay, यहाँ पे क्या इशू हो रहा है? यहाँ पे कुछ नहीं है, कुछ नहीं है। सबस्ट्रिंग प्लस हो गया। यहाँ पे भी सेम मिस्टेक वो वाला कर रहा हूँ मैं। I mean, the dumbest solution to this would be, we say over here we put a check on I saying if I plus 1 is outside the range, then just, commit the changes. But that is not how we should want to do this, right? Um, righty, righty. Um, I mean, I guess another solution could be just like paste this statement over here as well, right? Because this will anyway check the substring. Might as well work. Interesting. What is the thing? Output 5 expected y o h p h. Um. Hmm. 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 This is good. If it's not in that position, then we can't do anything. But other than that, it could be anywhere over here. And yeah, so we essentially just want to start from this and increment that to that. I think I understand what my mistake was. um, yeah, so what this could look like is um, sub substring dot index si, right? Pretty much take it from there, and then I will do substring plus equal si. That makes sense, because then what we're saying is, okay, jahan tak ye hai, and case 3 is like kuch kuch kuch. So we do pwwk, right? Pwwk. Yeah, so here mein problem aa raha hai. This is very dumb, by the way. We'll remove that. um, then we can just replace it and then do that. Yes. um, uh, okay, I think I'm just going to do a check. This weird check. It's gonna be something like, so we just have s is gonna be like pww, and it's gonna be pww actually. I'm gonna say substring dot not found, so to speak. Um, my bad. Uh, W W को include नहीं करना है. W को include नहीं करना है, so to speak. Oh, I'm talking about. That's what I'm talking about. We need to play the smart chat. Yes, let's go. Finally able to solve this. Um, yeah, so this is way too complicated. But yeah, let me just try to paraphrase. So we just do that, obviously, and if it's at the end of it, like if it's the start of it, right, we could pretty much say, okay, we could say, okay, so if it's at the start of it, we can say, okay, we can replace it. Um, we can replace it and then add this, right? Because at the end of it, so we can pretty much disengage it. But if it's not at the end of it, that means you can't take things over here, because if you remove this, then this becomes not technical. So what we do is we remove this. Hmm. Okay. Okay. Whew. Crazy, bhai. Crazy. Crazy, hai, bhai. Obviously, there will be a better solution of this. I don't know my solution. It's often. It's often. I would say it's often. That took a while. How long have we recording for? Wow, 1 hour and 30 minutes. That's great. That's crazy. I like green colors. Anyhow, let's see this. Let's see the solution. Give me a moment, guys. I'll just go wash my face. I feel like I'm a bit asleep. But yeah, that was a fun, very fun question. Meet you in a bit. We're back again. So before I watch this video, I just want to formalize my understanding of this question. So how do we do this question? Our basic understanding of a sliding window, the way we solve this, is what I'm supposed to do is I'm going to start scanning this and makes a window, so to speak, and this will be added into our substring solution, right? Right. This is very complicated solution, and this is just for the cases. This is for the case if a string is perfect and does not go. So yeah, so obviously whenever we see this, and if this, I mean, to be honest with you, if this is 0, uh, what I think, because we are basically doing, okay, we replace that with that. Um, doesn't work without this. Yeah, essentially works without that. So essentially we just remove this, right? And we just take whatever that is not common and we make this thing. We make this, we remove everything that, this has, anything that is there, and we take whatever that is left and we remove this. Now, for example, is PWWEWK. Now, the thing is, the moment we do this, that is great. This is repeating, so we remove this, but this is not a particular string. So what we do, the algorithm, in the way I think about this, is whatever is there behind this, well, that can't be a string with this, so the string can only be this, and so we take that into our sliding window, so to speak, and this is our final solution. And yeah, so let's watch his video. And yeah, this was a fun question to solve, and I was able to somehow visualize the sliding window in my mind, and this works regardless. So how can we make this better, so to speak? That's a good question. Let's format this. That's first thing. Um,
Let's solve LeetCode 3, longest substring without repeating characters. We're back to a classic LeetCode problem, the third one. So So this one's pretty simple. We're just given a string and we want to find the longest substring without any repeating characters, right? Like how these three don't have any duplicate characters, A, B, C.
This is O of n. Yeah, this is pretty much O of n. Um, you might argue that this is also like a search, but the thing is that if you see in the LeetCode also, where OM is length, yeah, makes sense. And as the time complexity, let's put it.
This one has two A's, so this would not count as a substring without repeating characters. And we only need to return the length of this substring. So the first idea that comes to my mind at least is, so just check every single substring, check if it has any duplicates. If it doesn't, then we're just going to take the longest one of those strings and return that doesn't have any duplicates. A C, that doesn't have any duplicates either. And then we get to the single substring starting at this first A. So we're going to keep this algorithm going even though we don't have to. Every substring we get after that, like, see how we're doing it? Every single substring after is
It's
also
useless.
going to have duplicates. So do we even need to check all of these starting at value A? This is the repeated work that we're going to eliminate with our very fundamental technique, the sliding window. So we want to only check substrings without any repeated characters. So let's actually just do that. Let's make sure that our window, right, our subarray, our substring is always not containing any duplicates. So once we get to this next A, we're going to say, well, now we have two A's. So we need to start removing from the left. We need to start shrinking our sliding window until we no longer have duplicates. So I'm going to say remove this one from our substring. Now our substring runs from here, from the B, all the way to the A. Now it's perfectly valid, so now we can keep going. It's still only length 3 though, so next we're going to add this B. But wait a minute, now we have two B's. But my question is, how would we even know instantly whether we had a duplicate or not? Well, we can use a set for that. Sets will only contain one of each character, so we'll automatically know if we have a duplicate. We can check it instantly. So we're going to check that we have two B's, so now we're going to keep popping from the left. We're going to keep shrinking our window from the left until we remove a B. And we're going to see that the first one we removed is the B, so now we're done. So now our substring runs from this C all the way to this B. Now we're going to add another character. Once again, we have a duplicate. And once again, we can literally just remove the farthest left character, and now we're valid again. No more duplicates. We're running all the way from A to C. Next, we add a B. The interesting thing about this is that now we have to remove this A because we have to shrink our window. Our substring has to be contiguous, so we have to remove this A. But notice we still have two B's in our substring, so we got to remove another character. We have to remove this B. So now our substring runs duplicate and do the same through quick set left pointer out. So the right pointer is going to go through every single character and pointer set, meaning it's a duplicate. Then we got to update our window. So we have to take the left character and remove it from our set. So character, then of course we have to update that left pointer, increment it by 1. And we're going to keep doing this while that duplicate remains in the character set. After we've removed all duplicates, then we can just add this rightmost character to our. At this point, we know for sure that our substring doesn't have any duplicates. The current window size is greater than 1 of string, we can return the result. If this was helpful, leave a like and subscribe, and thank you for watching.
Crazy. Yeah, I mean that was easy. Obviously, there's a much better way of writing such things. The way I wrote it, I wouldn't consider it the best way, even though for me this kind of makes sense. But yeah, sure. Oof, that was fun. That was fun. That was fun. I'm wondering now what I should do. You know, I have done enough of LeetCode. Should I put that in the LeetCode? Yeah, I mean, sure. Why not? Uh, the second copy, I feel like. Uh, yeah. So again, crazy, crazy, crazy. I think sliding window might be covered um, first, I guess. Linked list, I have no issue. This was, I don't know what this question was, buddy. Binary search, also, these questions I'm a bit troubling at. But yeah, I mean, it was fun. We are keeping up the grind, so to speak, you know. I like it. Is this? Oh, wow. Hmm. Hmm. What is this? Bro, I don't even know this. Okay, you are given an array of nums of size n. The ith element, uh, what? The ith, who am I playing against? The ith represents a balloon with an integer value of nums. You must burst all of the balloons. If you burst the ith balloon, you will receive nums I into these coins. Hmm. So we do 4, 2, 3. If I do this, it'll be um what? Return the maximum number of coins you can receive by burst. Return the maximum number of coins you can receive. If I burst balloons of 4, uh, if you burst the ith balloon, you will receive nums I minus 1 into nums I into this coins. Uh, okay. Must burst off all the balloons. If I burst up 4, so matlab I get 4, matlab इससे outer bound matlab we don't get anything. We get 4 into 2. Then iska we will get as 4 into 2 into 3. And 3 ka we'll get 4. Bro, is this prefix sum? Prefix is equal to 1, postfix is equal to 1. Um, I guess, uh, right, so for num in nums, um, right, we will um, make a re re I think I know how to do this chat. I might be onto something. Right, so well, for num in nums, right, I'm just gonna do actually, you know what, let's do something like this. for I in range of length of nums, um, what I'm gonna do, I'm gonna do pre I is equal to prefix, and then prefix is equal to prefix into nums I, right? So we have prefix postfix, pre is equal to this, and so we will essentially do for I in range, pre I is essentially equal to prefix something, L is equal to length of nums. Sorry, what the hell am I just doing? Mm, okay, so pre I is equal to prefix, and prefix equal to num of this. Okay, and over here we'll do pose I is equal to postfix. Actually, yeah, we'll just create one output array. So out, chat, I'm wasting my time. Yeah, so we'll essentially do out, and we'll do prefix of that, and we'll say out I is equal to out I into postfix, and we will do postfix is equal to postfix into nums of I, right? So now we have everything, and so for for n in out, so now we have, actually first thing is now we have everyone's that. So for um I in range of length of in L essentially, we have everyone का prefix. So इसका मेरे पास prefix है 1 and 4 2. Well, I have its prefix, means this is 1 into 4 into 2. Then I have this is prefix. This could be solved very easily, right? So um, so if I is equal to 0, then we'll do some special check over here, and if I is equal to L minus 1, we'll do some special check, and if not, then we'll just do else, right? If I is equal to that, right? If I is equal to that, so um, we will essentially just do out I, right? Out I already contains that, so we will just do out I into uh, nums I into nums I plus 1. We'll do out I is equal to out I this, um, oh, that's not what I wanted to do. That's kind of shit. That is kind of shit. That is very shit, chat, and I might fail this one. I might die. Um, What's happening? You will receive um 143. How? Ah, okay, so 2 goes away essentially if you pop it. Ah, okay. Like that. Crazy. Um, hmm. If I burst 4, then 4 goes away, then it's only 7. Um, I can do 4 right now. Get rid of 4. I could do something like that, right? So I could do something like I is equal to 0 while I is less than nums. While I is less than this, right? Um, right? If I can say if I is equal to 0, then we are dealing with obviously something that is much more disastrous. Um, the thing is, we want to like first of all kind of make this array into this, so to speak. And I'm going given a hard question. So, what topic is it? And how would I do this? So, okay, so we choose 4. So we go okay, well 1 into 4. Ma yeah. Chat, I got a forfeit. I got a forfeit. I forfeit. Like I won't be able to. I won't be able to do this. Um, yeah, I just wouldn't be able to solve this question. I'm sorry. Yeah, I'm sorry. I just gave up, bro. Um, yeah, but I guess burst balloons. Yeah, back to lobby. Yeah, that was shit. I'm so sorry. I got overconfident. I never did dynamic programming, and dynamic programming seems to be over here. Do we have the burst balloon? We don't have the burst balloon. Do we have entries? Um, hmm. So look guys, I think that would be it. I have to go and do another video. I think that video, I have multiple options. I wanted to contribute to open source, and the thing is I'm not able to set up the development environment as of now yet of the open library, so that's why I'm hesitant. I've tried multiple things, but I don't think it works on Windows that well, so I think I'll just do another fast API video or maybe a Go video. We never know. But yeah, thank you for tuning in to another lead code slash NeetCode grind. We're able to solve a few questions here and there, and yeah, see you in the next video. Bye bye.